Okay, here are some questions for transformation. Okay, basically we have to describe the transformation first and sketch the graph. Okay, let's do question A. In question A, we have to transform the graph y equals to x to y equals to minus 2x plus 1. Okay, follow the step of transformation, which is reflection, then dilation, then translation. Okay, we have to find reflection first. So when we see a minus sign in the graph, well, we should have a uh, we should have a reflection. So we have a minus sign in there. So what I can say, I have to describe reflection first. So we have its reflection. Okay, is reflection about y-axis. Okay. Okay. Then we look at the factor there. Okay, and we have, well, minus 2 times x, which we have a 2 times x there. So we now we go to dilation. We say a number times x, so we should have a dilation. Okay, so what I can say here is dilation. Okay, dilation by a scale factor from along, say, right. Okay, sorry. Dilation by a scale factor of 2 along y-axis. Okay. The third step is translation, and if there is a plus or minus, the function is plus or x is plus or minus a constant, we have a dilation. That's how we determine whether there is a translation or not. So we should have a translation when we say a plus sign there. Okay. So the translation is uh, one unit up, moved 1 unit up. Okay. So the graph should look like that. Okay, let's draw the graph. We know the standard graph of y equals to x is just a straight line like that. After a reflection on y-axis, it would look something like that. Okay. It should look like something in this shape. So we will have a straight line in this shape, and because it starts with in the origin, it moved 1 unit dilation, which we can't show it there. So it should be, okay, say, let's say this is, okay, so, okay, say if I have a dilation, this is your standard graph, y equals to x. Okay, your new graph should have a reflection on x-axis, so it should look like something that. Okay, and with the dilation by a scale factor of 2, so the new one after the dilation is something like that. Okay, and finally we have to move it up 1 unit, so it starts from the origin 0, 0. When we move it up, it will be 0, 0, 1. So your graph should be something like this here. Okay, and this point is 1, so y equals to minus 2x plus 1. This is your new graph, and the graph has one x-intercept, so we need to find this value for the intercept. We have to make y equals to 0 for x-intercepts, which we have 0 equals to minus 2x plus 1, and x is half. Okay, so at this point, the x-intercept is half, and that's done. Okay, this is our the right line is our new graph. Okay, now let's look at question B. Okay, we describe the transformation first. Basically, it's a parabola y equals to x squared, and it transformed to y equals to 5x plus 1 squared plus 2. Okay. Step 1 will describe the reflection, and from looking at the graph, I don't see a minus number times x or the minus number in front of any function there, so there's no reflection here. No reflection. The second step, we look for dilation, and we say 5 times bracket x minus 1 bracket square, so there is a dilation there with the times sign. Okay, so dilation by a scale factor of 5 along y-axis. Okay. And that's the only dilation we have. Now let's do translation. To find the translation, we need to, from looking at the equation, there are two translations. So we have minus 1 there and plus 2 there. Okay, so we must have a horizontal translation and a vertical translation. Okay, from the plus 2, we can find the vertical it moved, translated 2 units up. Okay, simple. For the horizontal translation, we have to make whatever in the bracket equals to 0. So x minus 1 equals to 0. X is going to be positive 1. So the horizontal translation is 1 unit to the right because we have a positive number. Moved 1 unit right. Okay. Now we can sketch the graph. Okay, let's sketch the graph there. So, okay, we know the shape of the standard graph of parabola is this shape, and there's no reflection, so the shape is unchanged.